AI-powered traffic management systems are easing congestion and reducing travel times. In other places, AI is being used to optimize energy consumption in buildings. When it comes to bridges, AI is also starting to make its mark. Researchers at Carnegie Mellon University have developed an AI system that can detect damage to concrete bridges by analyzing images from drones. The system is still in its early stages, but it shows the potential of this technology. In the Netherlands, the government is using AI to predict when bridges need maintenance. The system analyzes data from sensors that monitor things like vibrations, temperature, and corrosion. This allows officials to schedule repairs before problems become serious. Section 4. Crossing the Chasm: Challenges and Triumphs on the Road to AI-Powered Infrastructure. Of course, there are challenges to overcome before AI can become the go-to solution for infrastructure repair. The road to integrating AI into our infrastructure is fraught with obstacles that require innovative solutions and collaborative efforts. One challenge is the need for massive amounts of data to train these AI algorithms. This data must be accurate, comprehensive, and up-to-date to ensure the AI can make reliable predictions and decisions. Another challenge is the cost of developing and deploying these systems. The financial investment required can be substantial, and securing funding often involves navigating complex bureaucratic processes. And then there's the human element. Engineers, construction workers, and the public all need to be on board for these systems to be effective. People need to trust these AI systems before they're willing to rely on them for something as critical as bridge safety. Building this trust requires transparency and consistent performance from the AI systems. We need to develop clear guidelines and regulations for the use of AI in infrastructure. These regulations must ensure safety, reliability, and ethical use of AI technologies. Despite these challenges, the potential rewards are too great to ignore. Successful implementation of AI can lead to groundbreaking advancements in infrastructure management. AI has the potential to revolutionize the way we maintain our infrastructure. It can provide real-time monitoring and predictive maintenance, reducing the risk of catastrophic failures. It can help us save money, extend the life of our bridges, and most importantly, save lives. The future of infrastructure is bright with AI, promising safer and more efficient systems for everyone. Section 5. Bridging the Future: A Vision of Safer, Smarter Infrastructure. Imagine a future where bridges monitor their own health, alerting engineers to potential problems before they cause any disruption. Imagine a world where AI helps us design and build smarter, more resilient infrastructure that can withstand the test of time. This is the future that AI can help us build. It's a future where technology is used to improve our lives in tangible, meaningful ways. It's a future where we can drive across bridges with confidence, knowing that they are being monitored and maintained by the most advanced technology available. The future of infrastructure is smart. The future of infrastructure is AI. Let's build that future together.